It is truly an honor to be here. Thank you for coming to hear me talk. I am a NASA engineer. I trade. I've been a NASA engineer for a long time, as you heard. Usually I start off by asking how many people want to be an astronaut and go to Mars. All right. We're taking applications in the back. It's a new way to do space with our commercial partners, SpaceX and Boeing, and it's something that we'll talk about because it's a new NASA. We're moving away from the old adage of we cannot fail and failure is not an option to failure does lead to something. Maybe we can learn from failure. Maybe there's success in failure. And I don't know if anyone saw it just yesterday. One of our commercial partners launched not one, but 2 satellites on their rocket, and they did not stick the landing. So what they called that was a rapid unscheduled disassembly. they don't even want to use the word failure anymore, because in that they actually did some analysis already. They already learned what went on to fix the problem for the next time. So learning from failures, that's my theme today, that's my key today. Failure is an option. Are my slides here? How do I get to them? That way?
The other way.
The other way. Perfect. Okay. So I could show you some slides of some significant failures, and there's some good ones up there. The first one, Mars Climate Observatory, Mars Climate Orbiter. I don't know if anyone remembers that. I certainly do, because I was on the red team, which was the investigation team into the failure of that particular mission. So it made headlines because it was a multi-million-dollar, almost $1 billion program, and it augured into the Martian atmosphere and then hit the planet. The headlines read, NASA got it wrong because the units were wrong. They didn't translate imperial units to metric units. So, woe was NASA that we made such a simple mistake. Well, it wasn't that simple. And we learned from that mistake. We learned a lot from that mistake. So being on the red team, I looked into exactly why and how this particular problem happened. I interviewed the coders, the actual coder of the program that actually produced the incorrect data. Now, what this piece of code did was every time the spacecraft did a little maneuver to get rid of momentum, it messed with the trajectory, it messed with where it was going just by a real little bit. So they call it the small forces file. In past missions, the small forces file was no big deal because it was a small forces file. In this particular mission, because it was going all the way to Mars and it was wrong for all that time, it got to be a big deal because we're sending the data to the navigation team at JPL, and they're saying, okay, point here, point here, point here, and the last one was point here, and it pointed right into Mars. And well, we don't really know what happened to the spacecraft. We can only figure out that it had a rapid unscheduled disassembly. But the key was what we learned. So talking to the actual developer, he pulled out a piece of note paper out of a file cabinet. He said, "Ken, this is all I got to program what we needed for the small forces file." And I said, "Let me see it." And I took a look at it. He used to work for me, by the way, when I was at Lockheed Martin. So I had a good relationship with this guy. So there was no stories. He was not trying to protect anything. He did pull out from his file cabinet, and then he did show me the real live document that he coded it by. There were no units on that. Nobody told him. Nobody told him. So my recommendation, going back and on the red team, was we put in a standard, and we actually state in the standard, a requirements document shall be formal, and shall have units, and shall have all these other components to it, such that the developers know exactly what they're talking about, what they're going to code to. and everyone knows that we're all on the same page. That standard is now in practice. It's been in practice for many years. We're on the second rev of that standard. It's the NASA procedural requirement 7150.2b. And we're happy that it goes out on every single NASA contract we have, including our commercial partners who are just taking us for a ride. Literally, we're buying a ride. We're not actually buying the vehicle. We're buying a ride. So they're actually having to produce their software per the NASA standard. So I really don't think that we'll ever have a units problem again from bad requirements. So we learned from that failure. We learned a lot from that failure. Second one, it's a personal story because I did it. Hubble Space Telescope. I was coding up a bit 19 investigation. One of the bits in the computer was sticking and we wanted to see why. And I was tasked with coding it up and actually getting data from it. No problem. That's what I do for a living. I found that there was a slight possibility of, in between two instructions, another instruction interrupting it and taking the entire Hubble Space Telescope out of commission and putting it into what we call hardware safing, which means we're not taking pretty pictures from Hubble for 5 days. That's a lot of pictures. So coded it up, computed the probability, went through, everything looked good, never happened. This could never happen. The probability is millions to one that we could get in the situation that the processor was being utilized, all of the rates, and actually trip the problem that would take us into hardware safety. I actually saw it in a test once, but I ignored it because our test equipment was iffy at best. It was like sometimes it would work, sometimes it wouldn't. You'd go over and knock it inside, and then it would work some more. So I contributed that failure to a knock it inside kind of test equipment situation. We put it on board. New Year's Eve, right? New Year's Eve, 2 a.m. I got a phone call. Ken, Hubble is in hardware safety. And it was just 3 days after we put that patch up. And I was like, oh, it happened. And so NASA and its, in doing what they do after failure, red team was convened. Instead of me being on the red team was asking me the questions this time. And I had to pull out the piece of paper and say, these are the requirements, this is what I did. They agreed with my analysis of the probability. However, they also said that here are the set of parameters that happened right as the problem happened itself. And sure enough, those were the parameters that actually took us over the certain amount of CPU utilization and took us into hardware safety. So what did I learn? This is a personal story for me, so I learned something. I learned to sweat the small stuff. Never, ever let that small stuff go. I learned from that failure. I did not get fired. I didn't get fired. And I mean, putting Hubble in hardware safing, that's a pretty big deal, especially from a failure that we calculated a probability. That's a big deal. The software team rallied around and said, look, this is what we saw. We were behind you in this. It failed. Now we understand it. We'll take it out. We'll take that patch out. And to this day, I have yet to actually ignore any kind of a failure in a test environment whatsoever. NASA has had another failure like that with the Mars Polar Lander, that the hardware folks saw a transient on one of the legs coming down, and they ignored it. For one second, or one very short period of time, 1 millisecond, they saw the leg deployed signal. Let's ignore that. The real mission, the spacecraft was coming down. The legs said, okay, deploy the legs. We're at that time. When the legs deployed, by the way, it cut the engines off. So before the leg actually was deployed, it hit that transient, it said, legs deployed, it cut the engines off, and it made a hard landing and failed. So other NASA centers are catching on, but they haven't quite learned not to ignore that one test article. So that's a lesson that we're trying to share, and it's essentially a lesson that all of the software folks are seeing from us and our experience. IV&V down the road, the pink building. Everyone knows where IV&V is, right? The pink building. On NASA 4 and 5, I've heard it called all kinds of names. One person asked me if I work in the pink building. I said, no, that building is salmon, and it's the independent verification and validation building. So, and I told them what we did, so that's a good thing. But our job is to protect all of the software that is over a certain amount, or as humans, from making errors like that. So NASA has learned. That took many years, and it took a failure of a space shuttle and astronauts dying to actually get us in place and get us actually funded and move the importance of actually doing that assurance way up on the priority list. So that's good. We're living in different times. I know I have interns at NASA today. One tells me she's going to be the President of the United States in 2036, so I'm very much honored to have that. I am. I think it's great. Another one is a dietitian, and I said, okay, great. You can make sure that all the people are well fed on Mars and have a nice balanced food system on Mars, and they're excited about that. Another one is a cybersecurity specialist, and I won't get into what they want to do, but it's going to be very interesting as well. So we're not in we're in, but we're not in a pass-fail type of problem statement anymore at NASA. We're in a yes if, failure is an option, what can we learn from it? So it's an opportunity to learn and build. We have some unfortunate failures we never want to deal with again, and we protect against them. Those are the human type failures. However, in the non-human rated failures, the non-human rated missions, we do say failure is an option. And we say that the administrator actually says fail smartly, do it smartly. So learn from the failures. So imagine the inspiration of a generation that's willing to try and fail, and is taught at every opportunity the root of every failure, so they understand every single failure they have. My daughter got a C in differential equations. I got an A. She retained more defeat knowledge than I did. I know it because when she was asking me for help, I was like, oh, I don't remember. But she knows that stuff now, and that's important. So we go from failure to success, and we actually learn from those failures, and we don't like even to use the word failure anymore. So anymore, you can choose to use the words rapid unscheduled disassembly instead of that failure word. And this was a picture of some of the successes that came out of the failures. SpaceX actually hit the landing several times on water. So this is unprecedented. They're coming down out of orbit, out of Earth orbit, and sticking the landing on a barge. And the reason why they don't stick them all, sometimes they use up all the fuel getting this stuff into orbit, and so they're on minimal fuel. And they say, well, what happens if we try and fail? We'll learn. We'll learn. Nice Hubble Space Telescope picture. I mean, it's back online. It's taking pictures again. The Martian atmosphere. We put up another climate observatory for Mars, and of course, the space shuttle. So, again, so many intelligent people state that smart people learn from their mistakes, but real wise people learn from other people's mistakes. Thank you.